Hello everybody. In this video we're going to work another practice problem and we're going to work it together. So I would like for you to get some paper and pencil at the first pause if you don't have any on you right now. We're going to derive this statement, our target statement for all x for all y, LXY, everybody loves everybody, from these two assumptions. The first assumption could be read as saying everybody who loves anybody is loved by everybody. So for all x, if there's a y that x loves, then for all z, z loves x. That's the first assumption. The second assumption just says LTA, t loves a. Once again, we're going to do some goal assessment. We're looking at this generalization at the very bottom, and we need to ask ourselves how might we get it? Obviously, it's not up here among the primary assumptions in any obvious way that we could just break it off, so we're going to have to work on putting it together. So this will be the first time I ask you to pause the video and come up with an idea or two, like how do you think we might lead up to this generalization? What rule might we be applying in the final step or the final couple of steps of the derivation to get to this target sentence? So go ahead and hit pause, and when you're ready, when you have an idea or two, then you can resume the video. Since this target sentence is a universal generalization, the rule Universal Introduction should come to mind as a good rule that will give you a sentence like this as output. Once we decide on a rule that might help us, we need to think seriously about the input that this rule takes. And this rule, Universal Introduction, takes an instance as input. So what we need to do is form an instance of the generalization that Universal Introduction will take as input. I'm going to go ahead and insert a name here for the x variable, that we're going to replace the name with the x variable and add the universal quantifier. And I chose the name C, but there are many equally good choices here. There are a couple of really bad choices, though, and I want to draw those to your attention. We see two names up in our primary assumptions, T and A. Those two names absolutely cannot be in this position after the L, because if they were, we would not be able to apply Universal Introduction to that sentence. Okay? Remember that Universal Introduction has two provisos. It says that the name we replaced with a variable cannot be in the result of the rule application. So we'll be safe there. But it also says that the name that we're replacing with a variable cannot appear in any live assumptions. Well, there are two names in the second assumption, T and A. So we don't want them in a position where we would like to apply Universal Introduction. I'm not sure how far ahead you've thought, but if you thought that far ahead, you might also have thought, well, if we're going to get this universal generalization by Universal Introduction, maybe we'll get this universal generalization by Universal Introduction as well. That's a good strategy. And so again, the rule takes as input an instance of that generalization. And again, there are many names that would work, but two things that we can say, or three names we can rule out. The name here to be replaced by the y, and when we add the quantifier, cannot be T or A. Also, it cannot be C. Right? So those are the three names we can definitely rule out. If you chose another name, that's fine. It didn't have to be D. It simply cannot be the name that we have left in the generalization, because the name we replaced with a variable can't be in the result of the rule application, and it can't be T or A. Okay? So that's some good goal assessment. Instead of looking for this universal generalization, now we're going to be working towards this simple sentence, LCD. If you chose different names, again, that's fine. respecting all of the things that I just said. The name that you put in this new target cannot be the same name that you want in the rule application, and it can't be the name T or the name A. So what we want to do now is start looking at the generalizations or the sentences, the primary assumptions we have to work with, and see if we can imagine some moves down this derivation. So I'll ask you to hit pause and see if you can, just by looking at these, come up with a few ideas for how to move this derivation down. When you're ready, then you can resume the video. Okay, so one of the things you might think of is that we're going to have to, in order to work with premise one, we're going to have to apply universal elimination to that statement. And so that means dropping the quantifier. It means also, in this case, dropping the outer parentheses. And it means replacing these x's here and here with some name. And I'm hoping that when you choose a name, that you're also looking at the sentence you have to work with, LTA. So since T is in the first position, following the two-place predicate L in the second assumption, that would be a great name to put in for T, because it allows us to apply more rules, okay? So on line 3, we're going to apply universal elimination, replacing the x variable with the name T. So there's a y, L, T, y, horseshoe for all z, L, Z, T. You may also have, if you thought that far ahead, you may also have noticed that if you apply existential introduction to line 2, some good things start happening. When we apply existential introduction, we can choose any variable we like. But obviously, if we replace A with Y and add the existential quantifier, then what we have done is we've put together input for conditional introduction. So I'm going to go ahead and apply that for all Z, L, Z, T. That comes from lines 3 and 4, conditional elimination. Okay, so what we see here is that this name T, which was in the second position, the first position following the two-place predicate L, is now in the second position. So we've moved this T down. And that's just because when we instantiated line 1 to the name T, we got this conditional. In the antecedent of the conditional, T was in the first position. In the consequent of the conditional, T was in the second position. We need to think about that as we move our way towards this simple target sentence we have. We want to make sure that we have a D in the second position at the end of the day, and that we have a C in the first position at the end of the day. So what we see here is a little bit of a model for what might be about to happen here in the middle. It's a little bit challenging, but I want you to go ahead and hit pause and see if you can come up with some ideas for getting at least a little bit closer to this target sentence. See if you can think of at least, well, as many steps as you can come up with. Maybe somewhere between 2 and 4 steps should do it, or at least should get you moving. Okay, so go ahead and hit pause, and then when you're ready, resume. So here are a few moves that we might make to help us get going. Look what happens if we were to instantiate line 5 to the name D. Line 5, universal elimination. Okay, we have the D now in the first position after the two-place predicate. And if we look up here at line 2, we see a very similar sentence. We had LTA. And when we applied existential introduction to it, and we instantiated the universal on line 1 to the name T, we ended up getting T in the second position following the two-place predicate. Let's see if we can do all of that one more time. So on line 7, we're going to instantiate line 1 to the name D. So there's a Y, L, D, Y, horseshoe, for all Z, L, Z, D. That's line 1, universal elimination. And then what we're going to do on line 8 is we're going to do existential introduction on line 6, L, D, Y. It's line 6, existential introduction. And then, if you're like me, you see an opportunity to apply conditional elimination. It's almost irresistible. For all Z, L, Z, D. That's lines 7 and 8, conditional elimination. Okay? So now, let's look at this, 10, 11, and 12. If we look at lines 9 and 10, how are they related to each other? Well, line 10 is an instance of line 9. We can drop the quantifier, and the result would be LZD. If we replace Z with C, boom, we get line 10. So line 10 comes from line 9, universal elimination. Then line 11 comes from line 10, universal introduction. And line 12 comes from line 11, universal introduction. And we planned this very carefully. Line 10 is input for universal introduction because the name D does not appear in any primary assumptions, and the name D isn't going to show up in our resulting universal generalization. Line 11 is input for universal introduction because the name C does not appear in the result of the rule application, and the name C does not appear in any primary assumptions. Those names, C and D, were introduced in the proof by appeal to the rule universal elimination. And when a name is introduced to a proof by universal elimination, at least in that context, it's usually appropriate to apply universal introduction to it. Okay?